pretty much everything we do will be rooted in the context of music. Okay, so in our music project, we have to learn how to graph sound wave, right? That's going to look, if you have your coordinate grid, the sound wave will look something like this, right? But so far, you have learned what degrees are, right? Like you could calculate the sine of 90 degrees. Okay. The problem with using that measurement system is that degree measurements are a circular measurement system, right? So if I ask you where 180 degrees is, or 360, but where's 720? Yeah, it comes right back around here, correct? It's a circular measurement system. Okay, music is based in time, which is a linear measurement system. So we had to come up with some other way to measure time, measure linearly with degrees. Okay, they're called radians. Okay, and this is where we came up with radians. If I draw you a circle, and I said that the circumference of this circle is 2 pi. Right? Remember, circumference is. Can you calculate the radius? What?
Oh, no.
What's the circumference formula? It's what? Yeah, 2 pi r, right? So what's the radius have to be here? 2 pi's would cancel out, right?
Yeah.
Yeah, so we'd have a 1, right? So the r is 1. Yeah? You follow? Okay, so what circle do we know of has a radius 1? The unit circle.
Yay! That one.
Yeah. So how many degrees are in one revolution of the unit circle? 360, right? Okay, that 360 degree circle with a radius of 1 has a circumference of 2 pi units. Correct? Okay. 2 pi is the number of radians in a circle. Okay, so we've taken a degree measurement and now we're relating it to a linear measurement of distance. Right. So there are 2 pi radians in one revolution.
So are radians and radiuses the same thing?
No. They have the same root, but they are different words.
So radian, the number of radians is just the circumference?
Yeah, it's the circumference of the unit circle. So 2 pi units, right, is the circumference of the unit circle. That's where we get our measurement for radians. So right? So we can use this as our basis to convert between the two measurements. So if you have a unit circle at 45 degrees, right? What's the equivalent measurement in radians?
Say that one more time, sir.
How many radians is 45 degrees? So we have 45 degrees equals so many
Oh, isn't it like?
radians.
Oh.
There's a conversion formula. Okay. So basically what you're doing is 45 times
360.
pi over 180. This is the conversion formula right here. Okay, see how radians has a pi in it? So you're always going to have the pi on top. So 45 pi over 180, right? And reduce that fraction. What's 45 over 180? 1/4, yeah. Somebody said it. Okay, so this is pi over 4. So that angle measure is 45 degrees, but it's also pi over 4 radians. So just learn that those are equivalent statements. Pi over 4 radians is 45 degrees. It also happens to be the measurement of this arc length. Somebody said it? Okay.
Could you just do like 45 over 360 without that? And multiply that by
2 pi. You could. Damon.
Where did the 180 come from?
Well, let's look at this.
Oh, because you don't have the 265.
Yeah, so if I divide by 360, I get 1 degree is pi, and what's 2 over 360? 180, right? So that's our conversion formula. That's where it comes from. That's so, okay, so what would the conversion from radians to degrees be? Again, same basis. But we're going to move this over here, right? So what's the conversion formula? 180 over pi is a radian. So if I put up here, convert pi over 2 radians to so many degrees. Because you don't know what this is right now, your mind's kind of like, what is that in the real world? But you know what a 90-degree angle is, right? So if you have a radian measure right now, it's probably wise for you to change it to degrees so you have that picture in your mind. Okay, so pi over 2 times 180 over pi. Right, that's our conversion. Degrees. So the pi's will always cancel out, thankfully. And what do we get? 90 degrees, right? So you can relate those two. Because you know what a 90-degree angle is, you're still kind of questioning what pi over 2 is. So good to learn how to go back and forth. Okay. But again, we need this because time is measured in a linear manner. Degrees are circular measurements. So. Are you okay with that? All we've done is convert radians to degrees, degrees to radians. And what is a radian? Okay. So if I were to grab a unit circle, did the unit circle we put on Classroom have radians on it? Yeah.
Yes, I think it did.
I told you not to worry about it, right? Okay, so your unit circle, we just worried about degrees, so you should know that, right?
Yeah.
Now we can put radians on it, that's what all these are. Do you have to memorize those? Yeah.
No, because you can convert.
Yeah, all you have to memorize is the conversion formula, and you can do each one of them. You can memorize them if you want. I haven't memorized just because I've worked with it so long, but take 180 times pi over 180, there's pi radians. That's this right here. Okay.
So radius or whatever you're called.
Radians.
Yeah. Are the same degrees, like the same?
same but different. Fantastic, you got it. It's, yes, it's the same
Like just different measurement?
when you,
It's all different.
yeah, for all intents and purposes, in your minds, it can be, you can relate them as the same thing.
So it's like two words.
It's just basically the difference between time as a linear measurement, because I can't go back in time, right? I'm not Michael J. Fox. I do not have a time machine. So I have a linear measurement versus a circular measurement. So that's why we have a difference.
Wouldn't the radius?
So if I were to ask you, Kellen,
Wouldn't the radius be the linear measurement though?
the radians.
Radius.
The radius is a static measurement that doesn't change. Right. So, can you do, okay, back to the unit circle, what's the cosine of pi over 4? Or the cosine of 45 degrees, right? So that's the same as the cosine of pi over 4. Okay, same thing, right? So,
They equal the same thing, it's just different.
right, there's just two different names
So it's like
for the same thing.
two words, like a.
Yeah, that would be a good thing for it. Synonym. Yeah. Okay. So, yeah, good thoughts on that. Yeah. So if I have the unit circle, will give me this answer, right? I can do the same thing with radians, just like that. So again, this will be our time measurement music, right? Yeah, so this is what we're going to use as our time representation. So what's pi divided by 4? We have a calculator in a decimals.
It's 0.785.
Pi divided by 4
Yeah. Maybe I did backwards.
it is 0.785. You're right. So that would be the number of seconds the music has been playing. Okay, so this is the seconds or a time measurement, and then root 2 over 2. This will be your amplitude, your volume, right? So it will be the Y value of your sound wave. So you have a point, time, volume. Okay.
Oh, so it'll be
So for-
0.785.
Yeah, so 0.785 seconds into the music.
And then
The volume is going to be the output. In this case, it's root 2 over 2 in generic terms. But when you come up with your sine curves for these functions, you'll be able to set that volume at a specific level. But again, next couple days. What you need to be able to do is convert from radians to degrees and do this.
Can you show us like do an example?
Example what?
Like this one you just showed us.
The music.
Oh, the music thing. Okay, so I don't want to get ahead of myself.
Yeah.
Okay, your equation, do you want me to give you the big picture?
Yeah.
Yes.
Okay.
Mine.
All sound waves oh gosh. It's right there. All sound waves have the same format of an equation. Okay. So this is our end goal. Time, t is time, right? That's going to be our variable. You can put x there if you want. I don't care. B is the frequency of your note.
And are you gonna show us how you find that?
Okay. Those are, you'll just look it up.
Oh.
Okay, so remember when we have our song and then the chords, and you break the chords down into notes. The notes will be, each one will have its own sine curve. Right, so let's say one of your notes is an A. I believe one octave of an A is 440 hertz, if I remember right. So the sine curve for this
440 times 2 pi.
440 times 2 is 880
Times 6 seconds.
pi t. Okay, that's your equation.
So you'd plug in specific times to find the specific sine curve at the time?
You don't have to, but you could. This particular function has an amplitude of 1 because it's not out here. That number governs the volume. Okay, so 1 is fine.
So you're trying to find the
Okay.
time?
When you graph these, okay, you'll have a period to calculate and stuff like that, but this is your end goal, is to create that and graph it. Okay. But time is always in radians, that's why we need this. 'Cause you'll put real numbers in here. Okay. So that's it. Convert radians to degrees and be able to use the unit circle with radians. Are we okay with that?
I think so.
Okay. So what's the sine of 11 pi over 6?
11 pi over 6. Well, we use
11 pi over 6,
11 pi
right?
over 6.
And what's the sine value?
-1/2.
Negative 1/2. Okay. If you wanted to, you could convert this to 330 and then use your memorized knowledge, right? So,
Or we can just have that.
okay, so just be able to convert and to use the unit circle with radians, and I'm happy at this point. Okay. Pretty straightforward.
Yes, sir.
Any question?
Yeah.
Yeah. No?
We have a second.
Yeah.
Please come here.
Next year I'll come over there.
Okay.
Any questions?
I should have said
Yeah.
that.
Is that everything for today?
That's today.
Do we have homework?
Yeah, but I'm not gonna make it due until Tuesday, so. Because of all the stuff that's going on with homecoming, and then we had a sub the last couple of days. It's not on here. I did print new ones. I thought I did. So 2 things I thought I did when I left. Print those, update classroom for this class. It's the only class that we do.
Good job.
Well done. Most, there you go. 6.1. Most of it, well, about half of it's review problems. It shouldn't take you very long.